Okay, thank you very much. So in this talk, we're moving topic. We're going from Macs to supercomputers, and well, in the past this was the case. There are presently no big supercomputers using macOS anymore, so there's no homebrew anywhere in sight. So instead, I'm going to talk about how we combine some package managers, Nix or Gentoo Prefix, Lmod, EasyBuild, and Compute Canada with CVMFS as a distribution mechanism. So my name is Bart Oldeman, and I work for McGill University in the Compute Canada umbrella as a software installation coordinator. So Compute Canada, just to give you an introduction, it's a collaboration of advanced research computing centers scattered across Canada, mostly universities, some other research institutions as well, hospitals, etc. And we provide access to supercomputing to all researchers at Canadian institutions, and there's mostly professors and their postdocs and research students. They can get access to our HPC clusters. And what's special about our system is that we just have a few big clusters scattered across Canada, but we have support staff at pretty much every research institution in Canada. So we have some places where there is no HPC cluster, but we do have staff that help users on the cluster. So we have really a national system of supercomputers where the users can log into any cluster, but they can be helped by people across Canada and also by local people at their own institution. So what we wanted to do in 2017, when we moved to a system with fewer, is that we wanted to have a consistent setup so that people could move from one cluster to another one without seeing a great change in their way of operating. So they don't see a whole different cluster, and they don't have to change their whole workflow. They can have their existing script and make minimal changes to do the same computation on a different cluster. So what we do to enable that is to have a certain software mechanism. And what we do know about supercomputing is that, for instance, if you look at the top 500, it's nowadays 100% Linux. There is no Mac OS or Windows or FreeBSD in sight. We're all using Linux, but you can have different Linux distributions. In Compute Canada, there are mostly different versions of CentOS or now Rocky Linux. Across the world, you'll see some SUSE, you'll see some Ubuntu used, but that's about it. And so we have software that we distribute using a file system called CVMFS. I'll get into that later. And we have our software stack that we use that's independent of the underlying distribution. As long as it's x86, it will generally work. And then we provide what is called software modules using another build system called EasyBuild. And we have we provide software using modules using a system called Lmod. I'll get to that in a minute. There's actually some similarities with Homebrew here, is that we also install packages in version directories, but we provide them to the users not via symlinks, but via environment variables. So to get to you from a background is most HPC clusters use enterprise Linux distributions for good reasons, and those reasons are that at the bottom, looking at the Linux kernel that's being used, we need vendor support for the network parallel file systems, etc. So for instance, they use very fast interconnect, InfiniBand or OmniPath to get super fast networking between the nodes in the cluster, and that needs to be supported by the vendors. So you tend to have enterprise Linux distributions, and the problem with those is that their base software stack is often out of date because those enterprise distributions, they last for so long. So what you see is that most clusters around the world use some variation of CentOS or Red Hat 7, and their software stack for people who run now Linux on their laptop or their own computer looks very, very ancient these days because there's the old GC 4.8 and an old Glibc, an old Python. And if you look at CentOS 8, that newer clusters have a somewhat more modern stack, but it will still quickly run out of date in a few years. And then you compare to what they run locally, and you have just released Fedora 35, and everything is much, much newer. Linux kernel 5, GCC 11, Glibc 2.34, Python 3.10 already. And what we see is that users on compute clusters, they want the newest and greatest software. So we have a solution for that, and that's been going on for many years, which is not on this slide, because people just run documentation and they see a wiki page for their favorite software and said, in order to install this software, you need to type sudo apt-get install python 3.9 -dev. And they try to type that on our compute cluster and they say, sorry, sudo is not allowed for very obvious security reasons, but the users are not aware of that. And the wiki page authors never considered that their software may be used on a shared system. They're all aimed at individual laptops. So this won't work. So what instead is done is that clusters around the world, they provide what is called software modules or environment modules, where they write a file that can be loaded into the environment and modifies some parts of that environment. So, for instance, on an older cluster, we had a Python /279 module, and users would do module load Python /279 and would change the path, LD library path, C path, man path, a couple other environment variables. And so after you type that command module load and you type Python, you don't get the system provided Python, which at the time was still 2.6, but you'd get Python 279. And this is somewhat similar, the path name to Homebrew, but instead of using symbolic links to collect them into a single directory, we changed the environment, but you'd still have versioned subdirectories. And unlike Homebrew, we then have many versions installed at the same time, so you also have like a module load Python 3.4.3, and you get that per Python version instead. So historically, what happened is that the module files were created all manually. So I joined Compute Canada in 2012, and at that time, this was still what the vast majority of sites did, is to create all those module files manually. So a user wanted to have a certain package installed, we downloaded the package, we did configure, make install, and then we copied an existing module file, we edited it, and we put it in the right place, and they could load it via module load. Now, that didn't scale, it was too much work, and every single site did the same thing, and we decided not to reinvent the wheel all the time. And so from that, we got EasyBuild, originally developed at the University of Ghent in Belgium, and adopted by a lot of sites around the world. And EasyBuild is somewhat related to SPAC in the sense that they both try to automate software installations aimed at HPC clusters, but their viewpoints are a little bit different. So we're somewhat competitors, but just our end goals are more different. And for EasyBuild, it's more aimed at cluster installations, not so much by the users themselves, but by administrators, and for SPAC, it's mostly by the users themselves. So the system we came up with to automate this is to have a multi-layered system where we have a compatibility layer. Everything is newer than the base OS, so we have every user-oriented software newer than what's provided by CentOS 7, provided with a custom glibc where we install a bunch of packages that are always found on any Linux distribution, like the GNU Libc, AutoTools, Make, Bash, you name it. And On top of that, we install modules automatically using EasyBuild. And at the bottom, there are things that are still provided by the underlying operating system. Like the OS kernel, and sometimes there are proprietary packages that we cannot distribute. So the compatibility layer, for that one, we used to provide it using Nix and Nix packages. That got us into some issues that I'll talk about a little bit later. But we moved in the end to Gentoo Prefix. So what we do to make a consistent interface is that we don't just distribute packages by clusters downloading them as you would do with RPMs or some other package manager, that you download the package and you install it. No, we actually distribute the file system. And this idea was originally pioneered at CERN. And so there's a file system that is propagated from what is called the Stratum 0 server into Stratum 1 distributing nodes into clusters or individual laptops that may have caches themselves also locally, and then client nodes that mount a file system which has all the software installed. Obviously, that has to be in a read-only fashion, so only the data entry side can modify the software, and the client modify the software, but sees the same as all the other clients. So we have a particular directory /CVMFS that's the same on all the clusters within Compute Canada and anybody else who wants to mount it. So to get a little bit more deeper into what we provide, we have a compatibility layer provided by Gentoo Prefix these days, which uses a package manager called Portage, and with eBuilds we install various core packages. We bootstrap the Gentoo Prefix on the underlying operating system, and then we install what we need. And it's mostly at the base level, like anything that's not really scientifically interesting, but you'd find in any reasonable Linux distribution. So we're looking at the core utils, at org-grep, bash, bison, flex, NuMake, etc., etc. A whole ton of libraries. Also OpenSSL, which means that every now and then we have to do an in-place security update. And mostly provides newer versions than what is in the underlying enterprise distribution. And that itself is put into the one module that we write manually, which is a Gentoo/2020 module, which then modifies the path to point to that Gentoo Prefix installation. Now, if you know about Gentoo Prefix, it provides a bash script that you can use start prefix, but instead of running that script, we provide it via a module, and you load it, and then everything gets set up to do the right thing. Now, on top of that, we use EasyBuild to install software, and it creates the modules automatically. So it all automates what used to be done by hand about a decade ago. And Lmod is the module management system. So when you type module load X, you will load a module, and it modifies the environment, and that managing of the environment is done by Lmod. So you can load a module, unload, switch modules, use the same software compiled by different compilers, etc., etc. So all these builds are performed through recipes. That's basically the same across any package manager and homebrew. You also have recipes that are provided by, like they just call them brew. I think just brews. And for Nix, you'd also have recipes, and for Gentoo overlay, they call them eBuilds, and for EasyBuild, we call them easyconfigs. But they're all pretty much the same principle. You have some rules, some options that you pass to configure and make and install to do the right thing. Sometimes could be CMake, could be sometimes something completely custom for software that doesn't use a standard build system. So we install software and then we decide, do we install it in Gentoo or in EasyBuild? So in Gentoo is everything that's sort of base, where we don't expect people to need multiple versions. But if we need multiple versions, we install in EasyBuild. If we have something that has some architecture optimizations that can benefit from AVX 512, we install via EasyBuild. When it uses MPI, used for clusters, node-to-node communication, we use EasyBuild. And so mostly our installers will install things using EasyBuild, and the base in Gentoo is not nearly maintained as often as EasyBuild modules. And so we then install it on a build node. We have a team of about 10, 20 people who can install software. Node, we test it on that build node. We have a test repository where we can test it on, even mount it on the clusters. By proot, you can manipulate the paths a little bit, and then we deploy it into production. So we started with Nix as a package manager for the compatibility layer. We found some issues with that. So if you look at in Homebrew, there were version paths which were then symlinked. Well, Nix take that to the next level, where instead of just having version links, you have symlinks into hashed paths. So every installation has its own hash, and if you change a little bit to the recipe, it creates a new installation to a new hash. So you get a perfectly reproducible environment. But for us, it was overkill. We didn't need the store paths for something that rarely changes. And also, we didn't use Nix in the way it's supposed to be used, really, because we had a read-only environment for Nix, which the users could not change. Whereas if you have a custom Nix installation, then users can install their own packages, and it can go in the Nix store, which is safe because they have their private hash directories, so they can just add to it. And that gives you a whole consistent system where the users use Nix as a top layer. We have EasyBuild on top of Nix. That didn't work so well because sometimes the hash path would leak into the EasyBuild installation. Then we could have some garbage collect when we upgraded software, and then the EasyBuild would still see the hash path, and the hash path was gone, and it broke. So that wasn't good. We needed something more minimal, and we found out about Gentoo Prefix, which basically just puts everything together into a single directory, and that was the minimal that we needed, so we switched to it. So at this point, we have about 1,000 scientific applications that we installed using modules. If you look at permutations of the version, the CPU, the compiler that was used, there's almost 10,000 packages installed. We also have Python wheels. I'll get to that in a moment. Is that when people install Python, they want to install some packages, and instead of downloading them directly from PyPy, we have custom wheels that are often optimized to work on our clusters optimally, and so they install those instead of the ones provided on PyPy. Now, if you get into challenges, so one thing that's Linux system is that because of Gentoo Prefix, we have a custom ELF interpreter that sits in a different location as a standard. So standard ELF interpreter is what every program uses, is under /lib /ld Linux x86-64, but we have it set in a prefix. And so every binary that uses Gentoo Prefix, it has that encoded as its interpreter, and we'll then look for dependent libraries in the prefix. That's how Gentoo Prefix works. And that works for stuff that we compile from source without any issue, because it puts that in at compile time. But when you download binaries, that falls down, and so we have a workaround that people can run a script on a directory, and all the binaries in that directory will be patched to look in the correct location. Now, sometimes this breaks down. While the library path, they can still use the system libraries and things break down, so we tell people not to do that. Sometimes they do it by accident. Sometimes the commercial package using wrapper scripts that still believe that /user x11r6 still exists, which was deprecated more than 10 years ago, and they sometimes do funny things. We need to patch them. And one of the challenges on clusters that's not even unique to our system is with binary packages that are not always optimized. Anaconda is the main culprit, Julia to a lesser extent, is that both of these solutions provide binaries that are not always compatible. Now, they are very good solutions aimed at single user systems, but on clusters, when we have 10,000 users that all install Anaconda in their home directory and get some dependencies out of Anaconda themselves, which are sometimes also provided by our stack, then things get very messy indeed, and we can get non-optimal custom installations of various dependencies. So we're still looking for like a proper solution. Maybe with PackagingCon we can see what Anaconda and Julia are doing, and maybe even get a better solution on this. If all else fails and people cannot work with our environment, they can just disable it. Module -4 purge will pretty much get you a standard enterprise Linux distribution environment. Now, this whole system of getting a consistent environment among clusters has been picked up places. One thing is that we can have a public part of the stack that can be distributed, so excluding proprietary packages. Anyone can access this CVMFS system on their own computer, on a lab computer, on a laptop, in a VM. And so this opens up a new realm of possibilities. It can even be done on the Windows, on the WSL v2, because that's basically like a VM. You can run it on the cloud in virtual HPC clusters. For trainings, we can use that. For places like most notably the EASSI, European Environment for Scientific Software Installation. If you look that up, you'll see that they want to do something along similar principles, but instead of limited to x86-64, they also include other architectures, and they do things from the ground up and try to make it used more widely and for our more focused use case. Red Hat also has an article written about how to effectively use modules within Jupyter notebooks and in data science. So that's what my talk is about. Thank you for your attention, and let me know about any questions.
Thank you, but it looks like we don't have any questions yet. Well, I guess this. We don't have any questions so far. So I imagine we'll get some in the next few minutes. We do have one, which I'm going to have to copy over. But while I do that, how do you avoid reverse dependency problems where EasyBuild, EasyConfig would require a newer package from Gentoo Prefix?
If it requires a newer package from Gentoo Prefix, we have two methods to do that. One is to upgrade the package in Gentoo Prefix in place, but that's only if it's fairly innocent. We have done that in the past with something like Git, which is more of a top-level application. We can upgrade in place without too much trouble. If it's a library, and we would have it both as a EasyBuild module and in Gentoo Prefix. So in that case, the module will override what's in Gentoo Prefix. We've done that for something like CMake. Like we have an underlying CMake in the Gentoo Prefix, and there's some CMake modules for people who need newer versions of CMake.
And we do have a second first question from Jeffrey again, which is something I'm going to put on screen this time. How much work would it be to port from Nix to the Gentoo prefix?
To port from Nix to Gentoo Prefix?
That is the question.
Yeah. So the languages in which the Nix package builds are written are different than Gentoo EasyBuild. The ideas are the same. So I have ported a few recipes from Nix to Portage, and it wasn't very hard. It's mostly in the syntax. There's no automated converter script, but you could write one if you really wanted to.
Well, we have a bunch more questions streaming in now, but we are out of time, sadly. So if you could hang around on the element room that we have for the event
Okay.
and answer them, that would be great.
Thank you.
Thanks for the talk, Bart.
You're welcome.